Today we're going to be talking about DNS servers, DNS records, and we will conclude with a brief discussion on dynamic DNS. And with that, let's go ahead and begin this session. We're going to begin this session with a talk about DNS servers. Now, DNS is the process that maps human-friendly names, as in www.google.com, to their appropriate IP addresses. Without DNS, we would have to memorize all of the IP addresses that we wished to visit. Now, DNS stands for Domain Name System, and it's very structured in nature. If the local DNS server apparatus doesn't contain the needed record, it sends the request up the DNS chain until a positive response is received back. Now, this positive response gets passed back down to the original requester. Now, DNS does require that an FQDN, fully qualified domain name, is used in order for it to function properly. Now, an FQDN is the www.google.com. It's that naming convention right there. The www is the specific service that's being requested. The Google portion is the local domain that contains the specific service, and the com is the top level that contains the Google that contains the specific service. That is an FQDN. Now that we've got that covered, let's talk about the different levels of DNS servers. First off, there can be a local DNS server. This is the server on the local network that contains the hosts file that maps all of the FQDNs to their specific IP addresses in the local subdomain. It may be present or it may not be present. Then there are top-level domain servers, the TLD server. Now, these are the servers that contain the records for the top-level domains. Examples of top-level domains are .com, .org, .net, .edu, so on and so forth. Now, each of these servers contains all of their information for their respective domains, kind of. And what do I mean by kind of? Well, the TLD servers do delegate down to second-level servers their information. They do that to ease the load so that the TLD server is not overloaded. But the TLD server is the server that is responsible for maintaining the record. Then there's the root server. This is the server that contains all of the records for the TLD servers. So if you're looking for a TLD that is kind of unknown, you will actually go to the root server, which will then pass you onto the appropriate TLD. Then there are authoritative servers and non-authoritative servers. An authoritative DNS server is one that responds to a request, and that authoritative server has been specifically configured to contain the requested information. An authoritative response comes from a DNS server that actually holds the original record. So an authoritative response comes from the name server that's been specifically configured to contain that record. Then there are non-authoritative DNS servers. Now, a non-authoritative DNS server is one that responds to a request with DNS information that it received from another DNS server. A non-authoritative response is not a response from the official name server for the domain. Instead, it is a second or third-hand response that's given back to the requester. In most cases, when we send a DNS request, we get a non-authoritative response back. Now let's move on to the various DNS record types. The first record that we're going to talk about is the A record. Now, the A record maps host names, or FQDNs, to their respective IPv4 addresses. Closely associated with the A record is the AAAA record, or quadruple A record. This maps the FQDN to its respective IPv6 address. Then there's the CNAME record. Now this maps a canonical name, or alias, to a host name. What that means is that you can have edcc.edu be the same as edc.org without having to maintain two sites. The edcc.org can be the canonical name for edcc.edu. This works in part because of the pointer record, the PTR record. It's a pointer record that points out to DNS that there is a canonical name. And finally, we have the MS record. Now, this record maps to the email server that is specified for a specific domain. It is the record that determines how email travels from sender to recipient. And now let's move on to dynamic DNS. Now, dynamic DNS, or DDNS, permits lightweight and immediate updates to a local DNS database. This is very useful for when the FQDN, or hostname, remains the same, but the IP address is able to change on a regular basis. Dynamic DNS is implemented as an additional service to DNS. And it's implemented through DDNS updating. Now, this is a method of updating traditional name servers without the intervention of an administrator. So there's no manual editing or inputting of the configuration files required. A DDNS provider supplies software that will monitor the IP address of the referenced system. Once the IP address changes, the software sends an update to the proper DNS server. DDNS is useful for when access is needed to a domain whose IP address is being supplied dynamically by an ISP, or Internet Service Provider. That way the IP address can change, but people can still get to the service that they're looking for. Now that concludes this session on the introduction to the DNS service. We talked about DNS servers, we moved on to DNS records, and then we concluded with a very brief discussion about dynamic DNS.